Hello, I'm back. So this is what you should be watching, technically third because I had that example video, or the video we were supposed to watch at the end of class yesterday up there for you to watch. So if you have not watched the review from yesterday or the other video, then stop this and go watch those videos. Also, if you haven't read page 173, you should also stop and go watch or go read page 173 about thermal expansion. So we talked about temperature, we talked about thermal energy. Now we're going to talk about something called thermal expansion. So essentially when the temperature of a substance increases, the particles have kinetic energy. Okay, so we know that when something is heated up, the particles move a lot faster. Okay, because temperature describes the particle movement. Oh, Boo wants to say hello. Hold on, my kitten's right here. She's not taking no for an answer. Everyone say hello to Boo. Okay, Boo is going away now. So when the particles move faster, because of their higher temperature, they start to move apart and expand. Okay, they start to move apart and cause the substance, if they're in a substance, to expand. So this is what thermal expansion is. It is the increase in volume that results from an increase in temperature. They have so much energy that they don't want to be confined to that substance anymore. So the substance begins to expand. And what this does is it causes a change in density. So remember, density, and I'm just referring to what is on page 173, is the mass per unit volume of a substance. Okay. The example they give in your textbook is a hot air balloon. So when air in the balloon, the hot air balloon becomes hotter, the temperature increases, the particles get more energy, so they are going all crazy, and that expands the actual hot air balloon, and the air inside the balloon becomes like warmer and less dense. We've talked about density between warm and cold, where the air around it outside becomes colder than it and more dense, so it helps the hot air balloon travel upwards. So I'm going to just show you this little demo, even though the balloon's going to pop and my cats are going to freak out again. And actually, I got kind of scared too. So I have a candle at home. Don't play with fire at home. Don't do this at home. Okay. And I have a balloon. All right. So thermal expansion, obviously, again, it's going to increase the air particles that are inside this balloon. The temperature is increasing. They have more energy. They will cause the balloon to expand. You might not be able to tell, but I'll be able to tell, man, to the point where the balloon will pop. Okay, because there's not enough room for as much energy as these particles have. So I have my candle down here, and yes, this balloon is going to pop. So just don't freak out. So I'm not gonna hold it right on top of it. Sorry, I get a little nervous myself. So I'm not gonna hold it like right on top of it, but oh my gosh, there it goes. Okay, and there goes the candle. But anyway, that happens because of thermal expansion. So much energy, and you could see I wasn't even holding it like on the flame, so you can't blame, well, the rubber of the balloon was melted by the flame. No, it was because the balloon started to expand and eventually popped because of thermal expansion. So I do have another second video for you that goes over some more examples of thermal expansion that are in everyday things like railroads. Railroads actually have they're built a special way to allow for thermal expansion to happen. It'll go through that. It'll go through bridges. I mean, all different types of stuff. So enjoy, and please email me if you have questions.